a few conjectures. We're going to go into the computer lab and explore a few other conjectures, but the first one is really easy, and that one is a linear pair. And if you remember from the chapter 1, right, a linear pair are any two angles that are next to each other, okay, and along a line, so that share a common side. Do you remember that? So who can give me an example of one linear pair? Go ahead, Brecken.
3 and 4?
3 and 4 would be a linear pair. Who can give me another example? Harrison?
2 and 3.
2 and 3. So those are all linear pairs, okay? Who wants to make a conjecture about a linear pair? Yes, Stephanie.
The angles of a linear pair add up to 180.
Very good. They add up to 180. So you kind of already know that, right? But that's what you write on your first conjecture, that linear pairs add up to, linear pairs add to 180, or you could say they're supplementary or something like that. So then you'll have some homework based on that. That's pretty easy, right? Okay? Then we have vertical angles. So we have vertical angles. Who could give me one pair? How do you spell that? Vertical angles. Okay? Who can give me one pair of vertical angles? This was in the last chapter. Go ahead, Sam C.
1 and 4.
Oh, I got the wrong Sam. Sorry.
Oh.
Sam C. Go ahead.
2 and 4.
2 and 4. Who can give me another pair? Sam M. 1 and 3. So angles opposite each other when two lines cross, those are called vertical angles. Or they're angles that do not share a common side, but share a common vertex. So like 2 and 4, or 1 and 3. And we already defined them in the last chapter, right? Now, who wants to make a conjecture about vertical angles? What do you think is true, Chris A? Very good. Okay. So vertical angles are congruent. Okay. And I'm going to do a little proof with you using deductive reasoning to show why they would be congruent using the idea of a linear pair. So just kind of follow on with me. You might want to write this down. What do you know about the measure of angle 1 plus the measure of angle 2? What do you know about those? Makana? Those equal 180. So a lot of times when we have proofs, we make a little table like this. This is called a two-column proof, and this is kind of the traditional kind of proof. You will do flowchart proofs, but I just kind of want to introduce you to a proof a little bit. You have a statement, and then you have a reason, okay? And the reason is, this is like their linear pair. Linear pair. And usually they put numbers next to each one. Okay, so they'll say, okay, this is step 1, and this is reason 1, which goes with step 1. That's not very good, right? And then 2, I also know. So what I'm trying to get to, I'm trying to show, for instance, show that angle 1 is congruent to angle 3, right? Angle 3. So let's try to do that. Now, what do I know about measure of angle 2 plus the measure of angle 3? What do those have to equal up to? 180 degrees, okay? Why? Because those are a linear pair as well, right? Right? Now in number 3, guess what I'm going to say? Since measure of angle 1 is equal to measure of angle 2, or plus measure of angle 2 is 180, measure of angle 2 plus measure of angle 3 is also 180, what has to be true about measure of angle 1 plus 2 and measure of angle 2 plus 3? I mean, yeah, you could say you could do that, or I could say that they're equal to each other. Do you see that? Because if this equals 180, and this is also equal to 180, then they have to be equal to each other. So basically what I did is I took this and I substituted in over here, okay? And I'm allowed to do that because I know that that's equal to 180, so I can put it on that side of the equation. So now what I'm going to write is that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And what I just did is I did something called substitution, okay? Where I substitute one equation into another equation. Substitution, okay? Now remember where I'm trying to get to. I'm trying to get to 1 is equal to 3. Does anyone see something I could do algebraically to show that 1 is equal to 3? Here, Harry.
I'll take away the measure of
Good. Okay. What Harry said to do is subtract the measure of angle 2 from both sides. Okay? Which I'm allowed to do algebraically. And when I do that, okay, I get, can you see that? Sort of. Kind of looks kind of sloppy. When I do that, I get measure of angle 1 equals the measure of angle 3. Does anyone know the algebraic property that allows me to subtract one thing from the same side, from both sides of an equation? That's called subtraction property of equality. So when you're doing a proof, you have to write, is that funny? Subtraction property of equality. And just, I probably won't make you do this, but when I was in high school, they made you do an extra step, which is to say, what was I trying to get to? I was trying to get to 1 is congruent to 3. But I have the measure of angle 1 equals the measure of angle 3. So I can go through and now write that the angle 1 is congruent to angle 3. Okay? And the reason for that is called, it's just definition of congruence. Because if two things are equal in measure, then they are congruent. Guys, so what I just did, do you follow the argument that I made? You understand what I did? So I said these two add to 180, and that's, I used deductive reasoning. That's a 5-step kind of geometric algebraic proof, and that's kind of what proving stuff is all about. Okay? All right, I'm not done yet. Okay? I want to show you some things that we're going to be doing on the next conjecture on your sheets. The next several conjectures you're going to be discovering using the geometer sketchpad. So I'm going to go to geometer sketchpad because I want to show you some things that you guys haven't really used too much yet. So what you're going to do, you're going to construct a line parallel to a point. I want to show you some things, okay? So here's a line. That's not a line. I used the segment tool, so I have to edit, undo that. I'm trying to show you some of the mistakes you might make. So this is the line tool, so I'm going to construct a line. And then they ask you to construct a point. So use a point, and you want to make, first they want you to label those points, okay? So, and they want you to label them A, B, and C. So the way you can do that, you take this tool and you click on this,
Oh, clever.
and this, and it will label them. if you ever want to change the name of a point, okay, you can double click on it and then you could change the name in there, okay? While you're in the, yeah, you could write a whole word, whatever you want to do, okay? Now, what they want you to do in the first step is construct a line parallel to this line through this point. I just want to show you these so you're not like blind in there, okay? So what you have to do is click on this, and when I give you these handouts on the little sidebars, it gives you little steps, okay? So to construct a line parallel, you're going to click on this point, then you click on the line, okay? A lot of times you won't get what you want because you have more stuff selected than you need to, so you click in the open space to deselect stuff, okay? So I'm going to click on this, I'm going to go up to the
Construct.
Chad. I'm going to go up to the construct parallel line menu, okay? And then you can drag points around, and you'll notice that no matter how I move these, since they're based on that construction, that those lines are always going to remain parallel. See that? Okay, yes, sir.
It looks like they're going to intersect like a really long time off.
No, they're not. I promise. Okay, maybe it's just your aim. Okay, so then the next thing that they ask you to do, please pay attention. They ask you to construct a line from this point, or that goes through this point and through this point. And the way you do that is you start. Notice that when I have my line tool, okay, this thing lights up. It kind of lights up, and at the bottom left, see where it says from point on the bottom left? You have to make sure you're on that, because if you're on the line, you're not on the point, okay? So you have to make sure things will get highlighted. And now it says from point, and then you drag down here, and you have to make that this point that I have my arrow on goes through point A, okay? And then when you release, then, whoops, I could undo that. Oops, I missed it. Here we go. Here we go. See, this is what happened. So let's try that again. Get my line. Okay. And then boom, boom. And it's lit up. Okay? So now when I select things, I clicked in the white space so I can select. Now these things are always connected at those 2 points. If I didn't do it correctly, when I move this around, it wouldn't be at point A anymore. Okay? So then what you're going to be doing is measuring a bunch of angles. Okay? And the way you measure an angle, did I show you that? Okay? Watch. Okay? Watch, watch, watch. I'm going to put a point on this line. Okay? You can put points anywhere you want. And I'm going to put a point over here on this line. So say I want to measure this angle. Okay? So the way you measure an angle, you go click on that point, click on that point, click on that point, and you go measure angle. Okay? And it will tell you that that angle right there, DCE, is 50.34 degrees. And if you notice, it's dynamic. So what that means is if I drag E around, no, not E. How can I move this? Okay, if I drag that point around, see that angle's changing, right? Another cool, you're going to be asked to add a bunch of angles together to discover some relationships, okay? I forgot to record. So, say I want to measure this angle over here, this one, boom, boom, and I go measure, where is it? Measure angle, okay? So that one's 126, which you would guess it would be, because what has to be true about this and this? Equal 180. Now watch something else cool that you can do, okay? I can go, where can I go? Go to number, no, go to calculate, okay? But you'll see this when you get in there. Now, I could click on this, that's that angle, okay? And then I could click on this plus that angle, okay? And I hit OK. And what's true about the sum of those two angles? They add up 180 just like we just proved earlier, right? Okay? You understand that? Now watch. if I drag this around, or sorry, point A around, those two angles change, but what happens to their sum?
Stays the same.
It's always the same, you see? So that's kind of cool, right? So what you're going to be doing in there, you're going to measure this angle and this angle and this angle and that angle after you construct all that stuff and make some conjectures about which ones are the same, which ones add to 180, and what they're called. Paying careful attention to what they're called. This thing here, this has a name as well. This is called a transversal. Like in a car, the transversal is the thing that goes across the axles. So the transversal is the thing that cuts the two lines. Okay, we're done.